clean. First question I had is, interpret that slope. So first of all, before you can interpret it, you have to know what it is. So what is the slope of our model? And I keep using this word model. I'm trying to hammer it over your head by hearing it all the time. When I say model, it's a fancy word for a what?
Graph.
Sure. You know what? Yes. Graph. A chart, a graph. What else?
Equation.
A visual, an equation. I love all these. Absolutely. All of them can be models. All of them can be models. How many of you think when I say model, you think of a little tiny plane that's like a scale model of a big plane? Right, that's a model too. It's not a mathematical one, although there's mathematics involved in scaling it down and scaling it up. So in this particular one, which piece of the model would help us find the slope? The equation, right? The equation actually has the slope contained in it. How? Let's math 60 move for a second. What do you look at in that model, in that equation model up there? Y equals 1.05x plus 33.1. Which part are you looking at to find the slope? Christy, help me.
One before the x, the 1.05.
Well said. The coefficient on x, right? There are two numbers up there, 33.1 and 1.05. 33.1, 1.05. The question is, which one is the slope? And it's the coefficient. Remember the word coefficient means? Yeah. Coefficient? Yeah. It's the multiplier, right? The constant number multiplier on x. I'll never forget this, and I always emphasize this because when I applied for this job 10 years ago, 11, 12 years ago now, they asked me, I was given a lesson on something similar to this in front of the entire math department. Super fun. And Becky Blassman in class, any of you? She's wonderful, absolutely wonderful. She said, what's the definition of slope again? They acted like students. What's the definition of slope? I said, well, by definition, it's change in x over change in y. And she's like, and why is that? And it was such a curveball. So how would you answer that? Why is the slope change in y over change in x?
Because it just is. That's what we're taught.
That is not, I would never ever use that as an answer. That's the, Mom, why can't I go out tonight because I said so? Not very satisfying, is it?
No, but I still can't go out that night.
But she might give you better reasons as to why.
Yeah, sure.
Like it's Halloween and you want to go out at midnight, people are going to run you over off the road. Or it's New Year's Eve and it's midnight and this is one of the worst nights to walk or travel. And, so there's reasons. You can give reasons because I don't want to. So I thought for a couple seconds. What did I say, do you think? I'm going to show you. Why is the change in y over change in x? Why is slope defined to be? You guys knew this already, right? You know that slope, we've been calling it rise over run, right? Which is the same as grade. But if from Algebra 1, at some point you learned that it was the change in y over the change in x. Or maybe if you don't like Greek letters, y2 minus y1 over x2 minus x1. You probably learned that at some point, yeah? Why? How come? How come?
Because it's the rise over runs. Well, it's like creating a triangle.
It is. It is. But why couldn't we do x over y instead? That's a very good point. Why couldn't we do x over y?
I guess the people who invented this system didn't label it that way.
Josh, I think you're... See, the thing is, I don't know the exact answer. Here was my answer. And I think you and I have the same answer.
Okay.
When you look at the model of a line, y equals mx plus b. We all know that. At some point you learned this, right? Y equals mx plus b. Remember what variable this is called?
Okay.
There's independent and dependent. Right? There's independent. Oh,
That's
here we go.
dependent.
Holy crap. He's your independent variable. He does whatever he wants. And this guy, as a result of him, is what he equals. And I like having the independent variable tied over here and the dependent variable depending on everything else. So I want this to be the bread, this to be the toaster, and this to be the toast. And I kind of want to have it by itself because I want to know what my toast is going to look like when it comes out. If I put a piece of bread in the toaster, I get a salmon steak, that's kind of cool. But I also like to know why. Something obviously happened over here to convert bread to salmon, in which case we'll make a lot of money. But I like having it in this form where y, the dependent variable, is by itself and everything else. So here's what my answer to Becky was. Well, this is change in y over change in, well, excuse me, let's start with that. This is an x, right here. What's this guy here?
Y-intercept.
That's a y-intercept, right?
Last
in the past. So even though it says b, for whatever reason, I have an answer for that one too. I'll give it to you in a second. It's a y value. So when you see 33.1 as the y-intercept, what does that mean?
When x is at 0, y is at that.
Perfect! When x is 0, y is 33.1. What does 0 correspond to in this model? 1990. So in 1990, according to our model, we should have had
33.1 million people.
uninsured people. Good! Perfect! So that you guys know what a y-intercept is. Excellent. So this is a y value. This is an x value. And this is a y value. What the slope has to be is a way to convert an x into a y. Because you can't add a y plus an x to get a y. You can only add a y plus a y to get a y. You can add y values, right? If you're at y equals 35 and you want to get to 39, you've got to add y equals 4 to it to get there. You can't add x equals 2, because if you start here and add x equals 2, you go that way. So in order to add y values, it's like apples to apples. You have to add apples to get a sum total of apples. You can add apples to oranges and have a nice fruit basket. But if you want to just get apples, you have to add apples to more apples. That makes sense. So my answer was, in order to cancel the x, you've got to multiply by something that has x's in the denominator and has y's in the numerator, because then the x's will cancel. That was my answer. And Becky sat back and she's like, I've been asking that question for 20 years here at COCC and no one's answered it yet. I was like, well, there you go. I have no idea if it's right, but at least it's an answer, and it makes sense with the context.
Yeah.
So anyway, that's why I think. So it really is the, you can't go out because I said so. Because the only reason I said that is because somebody created this equation, right? So, but because the equation is there, at least we can have an understanding of why slope is what it is. Good. Good. Now, Chrissy has identified the slope for us. The slope is the m, because it's the coefficient on x. Back to Jess's question, why is the y-intercept b? The slope wasn't always called m, historically. What does your TI call the slope? Did you catch that? Did you catch what your TI called the slope when you ran your TI? It didn't call it m. What letter did it use? Little a. Tell me your name again. Sumi, thank you. When you ran linreg, when you ran the linreg command on page 4, and it said y equals ax plus b, a equals 1.05, b equals 33.1, somehow slope became m. I had no good answer for this. Slope starts with s. M is the first letter in the word Mickey Mouse, Munster cheese. I don't know what else, but I don't know why it means. I don't know why it stands for slope.
Is it possible that it's the Greek name for slope, starts with
M, Greek and M is mu, or the coefficient of friction in physics. Yeah, and I don't know what the Greek letter for slope is. That would make sense, but then why B for the y-intercept? I think at some point someone changed a textbook. I swear to God, I swear. How many of you drink 8 glasses of water a day? Studies show you should drink 8 glasses of water a day. No study has ever shown that. But somebody believes that a study did say that, and it became urban legend. I think that's what happened with slope equaling m. I'm almost positive. AB makes a lot more sense. When you do quadratics, it's ABC, and you're used to that. AX squared plus BX plus C. I'm not saying to be dehydrated, by the way. I'm not trying to imply that. I'm just saying that no study, peer-reviewed study, ever said you drink 8 glasses of water a day. Stay hydrated. Drink water till you pee clear. But, that's the idea, right, Amy? That's your metric. If you're peeing clear, you got enough water in your system. I'm just trying to teach you that today. But the idea is, that's why I think M came from. It's just one of those things that got into a textbook, a well-read textbook, and spiderwebbed out. Josh, go ahead.
Completely forgot. It's all good.
Oh, it's okay. It's okay. I tend to have that effect. I do too much information at once. Cool. So anyway, our slope, therefore, is the 1.05. Our slope is the 1.05. Please tell me what it means. And give me you see how it says in context? I'm big on context. I love math. You know that. You figured that out pretty quickly. But I want to know what it means in context. Josh, go.
So, the rise divided by the run equals 1.05.
I love it. That's a pure mathematical answer, and it's perfectly correct. When I say in context, though, bring in the context of the data. The data involves people, and it involves insuredness of people, right? Yeah. So can you bring that in? Let me see. Jory, go ahead. Bring that in, too.
Every year, 1.05 million people are becoming more and more
You see, that fuses the context with the math. Each year, each additional year, 1.05 million more people become uninsured. Yep. There's an S in there somewhere. Sure. Yes. That's the importance. And this is how it ties back to grade, and this is how it ties back to similar triangles, and this is how it all ties together. That idea of proportionality. Each year. Now, if you want to get really fancy, you could put the word on average behind me. Or behind that statement, not behind me. In a sentence. Every year, on average, we gain about 1.05 million more uninsured people. On average. Because it's not exactly that, right? It's an average. It's an average. Go ahead.
But if we were referring to average, wouldn't we put that as a squiggly equals?
Oh, yeah, you can do that now if you wanted to, because that's not exact. Oh, yeah. You totally can do a squiggles for this one. Squiggly equals 1.05.
Because I was going to say, if you're going to say an average, then that should be a squiggle. If you're going to say this is what it is, then it can be.
But you could. The thing is, I want to follow that with. You could never say this is what it is, because this is just the best fit line. It's not the exact or perfect fit line. Yes, thank you, ladies. Go, Michael. Right?
Well, isn't an average itself a squiggly line? Like,
It should be based on data, because as Chrissy said about 45 minutes ago, that's not perfect line. The data goes like this, then this, then this, then this. So unless you want to go every 2 years, if you want to look at the whole system at once, you have to put a squiggle, because the system itself isn't perfectly linear. If it were, there'd be a one-armed man chasing us around. Right? I hate to keep going back to that, but data is not perfect. It is messy. Part of this class is learning how to deal with that mess. What can you get from the mess and the noise? Please, just
So if the slope is 1.05,
yes.
so that means 1.5 over 1.
Yeah, thank you. Yes.
So you would rise 1.5, and you only go over 1.
Mm-hmm.
That looks like a lot more.
Can you go ahead and say that a little bit louder? Just a teeny bit louder.
The graph looks like it's a lot more than just a run of 1.
Everybody catching that? When you look at that graph, and you look at the slope as 1, let's call it 1 to make life easy. 1.05 rounds to 1, right? Slope is 1. On your paper, would you please draw a line with a perfect slope of 1? This is such a good question, Jessica. Such a good question. Please draw a line with a perfect slope of 1. Don't turn around.